This is Team 5, and our project was Downtown Mystic Traffic and Transportation Improvements. We are
Warren Strong,
Fatima Mohammed,
Scott Separak,
and Christopher Caesar.
We worked in conjunction with SLR and Dr. Ivan to create this project.
goal of project. So Downtown Mystic is a historic village that has been experiencing extreme traffic congestion in its downtown area. And our project focuses on improving Mystic's congestion problem. Things we identified that contributed to traffic congestion in the downtown area are lack of parking accommodations, poor pedestrian accessibility, and lack of signage. Our goal is for this project is to alleviate congestion along Route 1 and Water Street, improve parking accommodations, and increase accessibility for pedestrian, all while preserving the charm of Mystic. Analysis of existing conditions. So the current art museum parking lot has 73 parking spaces, and the existing intersection of Route 1 and Water Street has a stop bar for Water Street and a full right-of-way for Route 1 and 2 crosswalks for pedestrians. There's limited access from parking lot to downtown storefronts, and during the peak tourist season, long queues develop along Route 1.
As mentioned before, the existing parking lot along Water Street holds 73 parking spaces. Our proposed parking garage design triples that, totaling 210 new spaces for the downtown area. The cost of these spaces is roughly $11,000 per unit and will allow more tourists to access the downtown storefronts along Route 1. In addition to the parking garage, we've designed several walkways which provide access to these downtown storefronts. In order to determine a viable redesign of the intersection of Route 1 and Water Street, we used traffic simulation software VISM to create scenarios for each of our design alternatives. After running the simulation for each, we determined the only viable comparison to existing conditions is a roundabout. Using the results from VISM, we were able to design a roundabout that we felt would compete with the existing road conditions seen along Route 1.
And here is a snapshot of our VISM video. Here we backdropped the video with a Google Earth image of the intersection. And as you can see, the box that was highlighted in yellow was a node box, which measures the LOS of each of the turns onto the roundabout. The way that we got our traffic volumes for the data was we went to Mystic in February and recorded traffic counts at the intersection, and then we applied growth factors and extrapolated those values to an hour to use for our traffic volumes in the simulation. And that's how we obtained our LOS results for each intersection.
the final design of our project will be based off of the traffic simulation as shown before, with the results from VISM as well as a conjuncturing software, HCS, to determine the best option for our alternative. And through our cost analysis and our LOS results, we did determine that roundabout was the best design for our final design, and we will use that in conjunction with the parking garage to determine the amount of increased traffic that will come through the area. And this will allow for a consistent movement of vehicles through the intersection while protecting all pedestrian movement along all three legs of the intersection.